So hi candidates, very good evening. This side Ankit, and we'll just wait for 5 more minutes so that the rest candidate can also join us, right? And then we will probably start, right? So anyone, could you please confirm like am I audible or not? I am just sharing my screen as well. Kindly anyone confirm with this, right? Hello Tarun, Spurti, Sneha, Vivalakshmi, and the rest candidates. Guys, am I audible now? Tarun, just confirm with this. Okay, got it, right? So we'll just wait for 5 more minutes, right? Because the strength is very less, and then we'll probably continue, right? I have already shared my screen. Okay. So let's just wait for a few more minutes, then we'll continue, right? Okay, candidates. So let's just continue, right? Okay. So in the last class, we have already completed the unsupervised machine learning, right? So let me just open the same machine learning file, right? Okay, you can just go to this open notebook and just call this unsupervised machine learning, right? I have already shared the link with all of you guys. Let me just share this again. You can take a reference, and if you want to do it parallelly, you can just repeat the same step, whatever we are performing, right? So let me just give you the very quick recap, right? In the previous classes, we have just covered the unsupervised machine learning, and we know that it was completely based upon the features classification or like the kind of clustering or the grouping that we have to perform. Okay, so we pick some example related to the Insta Reel suggestions, YouTube video suggestions, movie suggestion, and so on, right? And the major important thing is that inside the unsupervised machine learning, we have three popular types of unsupervised machine learning. That is, the first one is K-means clustering, second one is hierarchical clustering, and third one is DB scan clustering, right? Why we are referring this all three important algorithm candidate? Because we can create a clusters based on the given input or like the features, right? And we know that when we use the K-means clustering, it just simply a concept of mean shift kind of algorithm where we have to find the mean or like the centroid that we generally refer this as, and we'll move that centroid toward the group or the clusters that we had just created, right? In the hierarchical clustering, we already knew that we have to use two different concepts. The first is called agglomerative approach and the second one is called the divisive approach. Inside the agglomerative approach, you have to use the bottom up technique, and you know that the bottom up technique is like you have to create the dendrogram, and the dendrogram is some sort of bottom up approach in hierarchical clustering. You can use this for different set of like different set of algorithms, right? And this bottom approach is called the dendrograms approach, right? And you can create this dendrogram, and this dendrogram will help you to identify the minimum required clusters, right? Forming this approach bottom to top is called the agglomerative, and the divisive is just the opposite of this, right? And the final one that is very important, which is important for the non-linear classification, it's called the DB scan. And inside the DB scan, we have used this that is called density-based spatial clustering of application with noise. And we know that inside this DB scan, we generally use three different concepts. The first one is called the core point, second one is the border point, and third one is the noise point, right? And we know that we have some sort of hyperparameter tuning. The core point generally decided by the number of minimum point that we generally give or that we generally consider. In like the basic example, we generally consider the four minimum point, and if any of the data set or like any of the point are surrounding with the four minimum points, you can consider this point as a core point. And if anyone having like the points less than the number of given core points, it's like the border point, and whatever the rest is called the noise point, right? You have two different parameters. The first one is called the minimum point threshold, and second one is called the epsilon, or like the radius of this circle or the clusters, right? So with the help of all three algorithms, we follow the practical concept, and let's just call some data set, and then we'll try to implement the unsupervised machine learning on different data set. Believe me, this is going to be very good, and you can just do this practically as well, right? So let's just start unsupervised machine learning practical part, right? I'm saying practical now, we have to create sort of different models, right? Okay, so let's just first start with the K-means. So the first algorithm that we are going to use is the K-means algorithms, right? We try to evaluate the model, and how to evaluate the model you already knew. Like we have some sort of different errors, and but in this unsupervised machine learning, we have to use the within cluster sum of squared error, right? We have already performed this in the last class, right? So let's just start with this K-means. Okay. So you have to import the important modules, right? So step one, import modules. The first module is pandas as PD. I can copy the same as well, but let me just quickly write this. Import matplotlib, sorry, byplot as PLT from sklearn. Okay, class. This time we'll try to import the dataset. We have the dataset from sklearn.datasets. You can just go to import option, and you will get this option that is called the make blobs. Blobs like binary like object kind of something this, and you can call the numpy as np as well, and finally you can just call the done, right? Okay, so in this first step we are importing the data set. We haven't like we are not still importing the k-means clustering or like like the db scan and the hierarchical. We are just importing the data set, and we know that in this data set we have to pick the features, and then we have to classify or like clusters the features based on the value that we are getting, right? So with this function make blocks, you can pick the number of data set that you want, okay? And that can be done by with this n underscore samples. It's like the number of samples that you want, right? So let this pick the sample as 2000 samples, right? And you have to give the by default values, that is called how many centroid that you want. So let's just take an example of like the 3 centroid or like the 3 different clusters that we want to perform, and the number of features that you want to give. So in generally for the practical aspect, let's just take this as a 2-part, right? If you just run this now, candidate, you will get 2 different arrays. Let me just give you the shape of this, right? So you will get the shape of this like this one, okay? First, let me just run this function, length function. Length will give you the 2 different data set. It's like one is for X data set and another is for Y data set. But we already knew that, right? In the unsupervised machine learning, there is no requirement of X and Y. But why we are getting the Y here, right? We will get the Y here, but we will ignore the Y part. We'll just only use the X part here, right? So let me just check the X dot shape, and there is no requirement of Y dot shape. So you can just simply ignore this one, right? We have 2000 of samples and followed by the 2 different features, right? Let's just simply call this X, and you can, if you want to plot the XSL, you can plot the X. Okay, this is the array that we are getting. This is feature 1 and feature 2. The feature 1 is like the salary score, and the feature 2 is like the spending score. Okay, so now this is the Y class that we have to predict. We have to cluster, but we will not use this one. We will create, or we will like form these clusters with the help of our model, right? So we can simply ignore this Y part, because in the unsupervised machine learning, this data set will give you the Y part, but right now it is not required to use this. because in this unsupervised, we are only allowed to use the X feature, and we have to decide the clusters based on that, right? So you can just simply visualize this, right? So let's just step 2 to perform some EDA part, and you can just call to this plt dot scatter plot. And inside this scatter plot, you can give the X part as well. Let me just call all the rows from the X1 and the 0th column. And again, all the rows from the X1 and the first column. You can just simply run this plt.show. Then you will check, okay, you have 3 different features now. And that is the reason you are getting this, okay? The feature 1, feature 2, and feature 3. Okay, not the feature 1. It's like we have 2 features, feature 1 and feature 2. And we are getting the 3 different clusters. If you will just run this now, you will get again different samples, and you will end up with like this. Okay, now you can just say, okay, sir, you have like mentioned here 3 different centers, but it is close to like 2 different clusters, the cluster 1 and cluster 2. But just look at this closely, right? It is a combination of 2 clusters, right? If you just run this code again, you will get different data set like this. Okay, right now it's very easy to identify the cluster, right? It's like cluster 1, cluster 2, and cluster 3. If you want to visualize this with the help of color, so you can just simply call this, the color is equals to Y, and this will give you the each cluster, or like cluster 1, cluster 2, and cluster 3. Now we are not allowed to use this Y, because the Y is the final cluster that we need to predict, or that we need to calculate, right? So what you can do, you can just pick these features. Based on this feature, you have to predict the cluster, you have to design the clusters, right? So let's just ignore this Y part and just simply call this plt.scatter. Right now, okay, you know that now, if you are working with the data set, right, the data set should be normalized. Okay, so we have 2 different techniques for the normalization. The first one is called the standardization, and second one is called the normalization. This is again the interview point of view question candidate: standard scalars versus min-max scaler. And we have a 2 different technique, and this is for the important point of view. When you want to normalize your data, you can use this standard scaling technique and the min-max scaling technique. In the min-max scaling technique, the data set will be like in your sort of minimum to value, a minimum to maximum value, right? Let me just visualize this, then you can probably understand this, right? Min-max and the standard scaling technique. Okay, you can use this for the standardization as well as for the normalization, right? And I think this should be the good one, right? Standardization versus normalization. Standardization versus normalization, right? Yeah, this is the formula exactly that you will get, right? And you can use the 2 different techniques. The first one is called the normalization. And in the normalization technique now, you will give your input data, and the input data will be end up in a range of 0 to 1, right? The minimum value will become 0 and the maximum value will become 1. And how to get this kind of solution? For that, you can use this min-max scaling technique. So if anyone is saying, okay, we are getting like very huge values at different scale, let's just scale this data into the like small scale. So you can use 2 different techniques. The first one is called the standard scaling. Second one is called the min-max scaling. The min-max scaling min-max scaling like follows the concept of normalization. In the normalization, your data will be like in a range of 0 to 1. The minimum value will be like 0 and the maximum value is 1, right? When you are using the standard scaling technique now, so you will like standardizing your data, and it's like the data, the mean of the data will become 0, right? You can just check this. The standard scaling, in the standard scaling, the mean is like 0 and the data is like inside in your 1 deviation or like 1 standard deviation. Okay, you can just simply check this one. In the standardization, the mean is close to 0 and you will get the final data set in like 1 standardization. So this is the best visual that you can pick. This is your actual data. If you're normalizing this data, you are getting the data in a range of 0 to 1. But if you're standardizing your data, so you will get the data inside your 1 standard deviation and the mean will become 0, right? So you have 2 different techniques of standard like scaling your data, and that is scaling your data is very important if you are getting the data from different scale, right? So this is very important for the feature scaling and for the data pre-processing, right? So how to standardize your data? So let's just write this. How to scale your data in standard scale, right? So go to this from sklearn. You will get this method which is called the pre-processing. You are pre-processing your data set, right? Instead of directly feeding your data inside the ML model, you are performing some pre-processing step so that the data is come to the standard scale, right? So you can just call from sklearn.preprocessing import standard scaler, right? And we know that standard scaling is some sort, the data will be in the one standard division, right? So you can just call this, you can create an object using this standard scaler. The standard scaler is a class, right? Let's just run this. And now what you can do, you can just simply go to from sklearn dot train test split dot model selection. You can call the train test split, and you can give your data into different part. And we know that the data set is like only we are using the X features because we are not allowed to use the Y part, right? But if we are using the train test split, now you have to give the X train and X test, Y train and Y test, right? So X train, X test, Y train, comma, Y test. Then followed by your data set, the data set that you have to pass inside the X data set, right? You can just pass the Y. You can give the random state as well. Random state as the 42. And just simply pass the test size as the 20%, right? Let's just call the test size with the 20% dot like this, right? Okay. You can just simply write this done. Okay. Too many values to unpack. Let me just simply check X train versus X test, Y train versus Y test, X train, X test, Y train and Y test. We are dividing the data X into Y. Random state is this. Two values to unpack. Let me just run this code again, right? We are getting the 200 features followed by the 3 centers. Got this. Perfect. Run this one. Shape are good. Okay. Run this one again. Okay. Too many values to unpack. Expected 3. Okay. We are like it said there is some sort of issue, right? So let's just simply check this. What is the issue? Simply go to this x.shape. We have 2000 like samples and then followed by the data set. Okay, now just go to this y.shape. Okay, let's just print the y value. Okay. Yes, we have dot dot dot. It's like we have the data set. Okay, you can just call the shape as well. If you're getting the error like the shape mismatch, na, it could be due to too many values to unpack, right? So it say we are getting the more values, but we are dividing. Okay, see the mistake is there, right? You have to give the comma, x train, comma, x test. I've used the underscore, right? That was the mistake, right? Now it's done. Okay, now you have divided your data. Okay, so what we have covered this, right? You simply call this data. It's like the make binary like objects, right? Make blobs, and you have converted this data into x and y. We are not allowed to use the y part because y is the thing that we have to predict or like we have to classify or to have create the clusters, right? We are just visualizing the data set with the help of scatter plot. We are calling the standard scaling to just keep our data in a standard scale or like within a one standard division. Then you are probably calling the train test split to just divide data into the training and testing part. Now the thing that you have to do, you have to scale your data, right? So you have to call this scaler and you can use this method which is called the fit and transform, right? And you can give your training data set because you want to scale your data for the X training data set. And whatever the data set that you will get at the output is like the X train scale data set, right? You can just simply call this as the X train scale. And you can do the same step with the X test scale as well. So let me just copy and paste this. And instead of X train scale, you can just write this X test scale and pass this as X test, right? Then followed by print done. This step is done, right? Now let's just call the K-means clustering. Then we'll call the different like the unsupervised learning we have. It's like the hierarchical and the DB scan as well, right? So let's just call the K-means. If you want to call the K-means, now you have to go to from sklearn dot. You need to write this cluster and then simply write the K here, right? If you write the K here, then hit the tab button or like control space on the Google Colab, you'll get this K-means. Okay. And now you know that you have to identify the number of clusters that is required to particularly give this kind of grouping or clustering concept, right? So for that, you need to run the multiple iteration. You are just saying, okay, let's just simply run the for loop, and we will start the value of k from 1 to different values. And then in the each iteration, we will try to calculate the WCSS. WCSS is like the within cluster sum of squared error, okay? So you can just write, let's just calculate WCSS at each value of k. Okay. So what you can do, you can just create an empty list of WCSS for I in range, and we will use the value of k from 1 to 20. We are using the 20k value, right? What you can just do, you can just simply call to model. The model is equals to K-means, and you know that you have to initialize the model. And once you call this model, now just simply call to this fit, right? If you call this fit option, then you can give your training data, right? See, in the fit part, we are giving the training of X and the Y as well. But right now, there is no requirement of Y because this is the unsupervised machine learning, right? Whatever you are fitting, it's like you are creating the clusters, right? And each clusters will give you some sort of the errors, and that errors is called within cluster sum of squared error. So you can just write this. This is important for the interview point of view, like within cluster sum of squared errors. Okay, within cluster sum of squared error. You have to calculate this, and once you calculate this, you can utilize the WCSS. Let me just append the model dot. Okay, the WCSS can be called by the help of inertia. Inertia is the error, right? Inertia is the error that particularly derived, or you are getting this value with the help of wrong classification or like the wrong clustering if you are creating, right? So you are just appending all your losses inside this WCSS. Perfect. Now once you run this loop, you can get the each value of WCSS. Okay, these are the WCSS, or like these are the errors, and how to find the value of k or like the clusters. So you can just simply write this. Okay, now let's just do one thing. We are just running the loop multiple times, but we are not giving the value of k. So let's just pass the value of k is like n is equals to cluster, and we will use the n is equals to I, and you can just simply write this as if the value of k is, if the value of k is f string, you can just simply give this I, then loss is something. You can just simply call this inside the model.inertia. It's like the loss. Okay, let me just write this as loss. Cut this method from here and go to this, and you can just simply say, instead of appending this model.inertia, you can just simply append the loss, and you can call the loss as well here, right? It will take some time. It will try to give the value for the each loss, right? And you are getting the value like this. Okay, don't need to print this final WCSS. If the value of k is 1, the loss is something this. And it is like if we are just creating only one cluster. Just look at this image. If we are creating only one clusters now, so we will get the highest loss. And once you move down, once you move, like increase the value of k, so you are just decreasing your loss value, right? Now you can visualize this loss value with the help of elbow method. Okay, so let's just call this elbow method to find the best k value, right? And for that, you have to visualize this one. So you have to plot the elbow graph, or like elbow curve, you can just say. So you can do one thing, you can just simply use this plt.plot, and whatever the data that you are using, it's like from value of k to value of 20, right? We are using the 20 value now, and then followed by the WCSS. Okay, you can change the color as red. Then simply go to this plt dot xtick. Xtick is like the x-axis value that you want to give. It's like the number of k or like the clusters. Okay. And then followed by the plt dot ytick. Ytick is like the loss value. It's like the loss value WCSS. And then you can finally show this graph plt dot show. Perfect. Once you run this, fail to convert the value of number to k clusters. What is the number to k cluster? Let me just check where's the issue. Uh, line number. Okay. So we are getting the value. Okay. But there is some sort of issue. Number of k clusters. Okay. See, the problem is that now we are using we have the different clusters value, right? It could be due to the maximum k value, right? Let me just check why we are getting this. So it's like 17.5, then we are getting some sort of errors, right? So you can just make it 15 and let's just run this again. And let's just run this loop again and just try this with like fail to convert the values to axis unit number of k cluster is the error, right? Class, let me just check where is the error. See, we are getting the graph, right? But the error is due to some sort of conversion, right? It's like unit XR, some sort of plt.xtick. We are using the plt.xtick. The WCSS is good, right? plt.xtick. Okay. Okay, got it. So the number of clusters. So my mistake, right? It should be plt.x label, right? It should be plt.x label and plt.y label, not the xtick and the ytick, right? And let's just give this xtick as range of 1 to 50. Okay. Now this is perfect, right? And now can it just calculate where is the elbow, right? You know that if you want to calculate the value of k, you have to use this elbow method, right? Elbow method helps you to identify the value of k, and how to find the elbow. You can use this one for the reference. Where you are getting the elbow, there you can select the value of k, right? So you can just check the value of 3 that we are getting is the good one, right? If you want to show the value for this line as well, so do one thing. You can just simply call this plt.plot and create a plt.bar as well for the same one. Okay. While we are creating the bar, although we are not going to use this bar, right? But we have some sort of shortcut to plot the values with the help of this bar value, right? And what you can do, you can just go to this plt.bar label and you can just give your axis, right? Okay, you will get the bar for the each value, right? But what we don't want this bar value, right? So what you can do, you can just simply go to this alpha parameter and you can turn out the you can turn off the color of this value, right? Now you are getting only the value of k, right? It's like 3200 and some sort of like this. Now you can just increase the value of the figure size, plt.figure. Just increase the figure size of this. It's like 15 by 5, some sort of like this. And where is the plt.bar level? This one now. You can just go to this. You can reduce the font size to 8. Okay, font size like this. Okay, now let's just run this again. Now you are getting the perfect value. At the value of 3, at the value of k is equals to 3, we are getting the loss value is like 267 some sort of like this. Okay, so in this way you can simply analyze the number of clusters that is required. Now what you can do, you can just simply go to your final model and you can just say the final model is equals to, simply call this k-means and call the n clusters as 3. Now you know that why we are taking this 3, because it say that with the help of elbow method we have to take the value of 3, right? And there is another parameter candidate that is called the initialization. We have to use the initialization as the k-means plus plus. What is that k-means plus plus? It try to resemble whatever the centroid that you are assigning. It should have like the huge distance so that it cannot coincide or like overlap one centroid to the other one, right? It has to be like the more different distance way, so that one centroid does not coincide with the other one, right? So you are initializing the k-means plus plus to just make it more distance way, right? So in this way we are creating the final model. Now with the help of this final model, let's just go to this. We have this method that is called fit and predict. This will try to fit the model and try to predict the values as well. Okay, now you can just simply give your X-train data set, but we have X-train scale data set, so you can give this one. This will give you the Y value, and the Y is like the 0, 1, 2. Although we don't want to predict Y here, but we refer this Y as a cluster, and we know that the cluster is nothing, just a group of some similar or like the feature data points. Okay, so you can store this inside the cluster. The cluster is like the Y target value that you are getting. Okay, now what you can do, you can just simply go to the, if you want to Y predict as well, so you can just go to the final model, and inside the final model you can use this predict method, and you can give the X test data set as well. Let's just give the X test data set scale, and you can simply store this inside the Y predicted value. And now you can simply visualize the Y predicted value with the help of visualization. See, why we are getting 0, 1, 2. 0, 1, 2 is like the 3 different clusters that we are getting. Although we don't need to predict the labels or like the Y values here. But here Y generally try to resemble the clusters, right? So you can just simply run this for the X test part, right? So just go to this plt.scatter, and you can just call your X dataset test, and let's just call the 0 value or like the 0 column, and then again call the X test, and then followed by the all the values at the row level and the 1 column, and you can just give the Y value, and the Y value, the color is like the Y predicted that we are predicting, and it will try to identify the clusters, right? You can just show this, right? plt.show. X and Y must be the same size. C X test 0 and 1. C is equals to Y pred. See, everything is good. X and Y must be the same size. X test. Okay, this is the mistake, right? It's like this one. Okay, now you can run this. So we are like ending up with this, particularly 3 different clusters that we are getting. And you can just say, okay, our model is able to create the clusters, and that clusters, we can use it for the further experimentation. Right? After X train, there must be a comma. Yes, Taruna, yeah. That was my mistake, right? Okay. So plt.scatter, some sort of like this. Okay, now we have created this kind of like unsupervised machine learning implementation with the help of K-Means. Okay, now let's just do one thing now. So instead of like doing this manually, you can just copy all the codes. You can run your for loop, and you can try to visualize the, if you're using the different K values now. So how does exactly this affecting your cluster? So let's just try to identify this one. Instead of printing this now, let's just create the cluster. Okay, so we will do one thing, model dot predict. We'll use directly this predict, and we will pass the X test, right? And you know that this will give you the Y predicted value. Okay, whatever the Y predicted that you are getting for each value of K. If you are having the K value as cluster 1, so you will get 3 different clusters, or like 1 cluster, 2 cluster, 3 cluster, 4 cluster, and so on, by varying by the different values of K, right? So let's just call this as ypred, and then how to particularly visualize this. So you can copy this code, and let's just paste this here. You can make it plt.show, and I want to clear out my previous visual with the new one. So you can use this display method, and you can write this argument display is equals to true, right? And let me just run this. Okay, so instead of printing something, you can just give the plt dot title, and inside the title you can give the clusters. Okay, instead of just write this, what if we have K is equals to I? And you know that the K is equals to I is like the cluster 1, cluster 2, cluster 3, and then followed by different cluster. Let me just run this. Okay, so class, you will get something like this, cluster 1, cluster 2. It's running very fast, right? So let's just do one thing. Let's just use some time concept, time dot sleep, and inside this time dot sleep, you can just give the 5 seconds for the each iteration, and let's just import the time module as well. Okay, so if you are using the K value 1, so this is the, so it will try to create a cluster for 1 color, right? If you are using the K value as 2, so it has converted the data set into 2 clusters. This one is cluster 1, and okay, in the cluster 3, why we are not getting the 3 different channels, right? We have to get the 3 different channels now. Okay, let's just do one thing. I am using x test 0 and 1 and c is equals to y pred. Yeah, this one is good. Okay, model dot pred. Okay, so the problem is now we have to use the x test scale, right? Instead of this now, let's just use the x test scale model dot predict whatever the model training we are using now. X train scale now, so we have to give the x test scale as well. And if you want to see model dot predict, we can use this x test now. Let me just check what we have used it here, right? So it's like model dot predict x test scale, model dot fit and predict x train scale. So let's just call this one the cluster 1 k1 and wait for the value of k2. If we are getting the k value 2 now, so we will get the two different clusters, and the value of k3 we will get the three different clusters, right? Yes, this one is perfect, like the cluster 1, cluster 2 and cluster 3. Now just wait for k value 4, right? This is the problem, right? If you're selecting the wrong value now, so it will give the different clusters. K is equals to 5. Now look at this. It will just try to show you the different cluster. K is equals to 6 is also good, right? But it's not just the visually appealing, right? You have to be very specific with the value of this one, right? And we will get the value of best value of K like this one. Okay, this is the elbow method technique where you can simply identify the value, right? It will try to run it up to the value of 15. Let's just wait. It's like the value of K is equals to 10. Okay, so in this way, candidate, you can do this, right? Now, we are just particularly using the approach of this one, which is called the elbow method. Okay, do we have like another technique where it can or automatically identify the value of k instead of using this manual approach? Yes, we have. So what you can do, let's just wait for to execute this one. You can use this method that is called the knee locator. We have this module that is called the knee locator, and inside this knee locator now, this will help you. You can just write this from need. Okay, you have to like install this. Let me just check what is the spelling. Pip install k and double ed, I think, right? Yes, you have to copy this. Pip install need. Go to this one first, install this, then comment this out. Go to this from k and double ed. It's like the knee locator, right? Import this inside this k need. You can just call this knee locator. Let's just wait for this to execute. Yes, perfect. Okay, is there any question, candidate? Is anyone asking anything, Taruna? Okay, so we can import this knee locator now. What you can do, you can just simply write this as okay knee locator. It's like k and double e knee locator. You can create this variable, and inside this variable you can just use this as knee locator. Okay, let's just do one thing now. It will, the name is same, so let's just call this as a kl knee locator, and you have to give the value of k that you wants to try. So you can just simply k, the value of k is like from 1 to 20, we want to try for the 20 value. You have to just give the WCSS or like whatever the problem, whatever the errors that you have calculated. Okay, so we have calculated the errors for the 15 data set or like the 50 value of k. So let's just give the value of key value, like the k value from 1 to 15. Then you can simply give your WCSS, and you have two different techniques. The first one is called the curve, and inside this curve you can give the two directions. It's like the convex or like the concave. Okay, so if the loss is, if the WC is on increasing side, so you can use the concave, right? It's like the in the decreasing side, so you can just use this for the convex one, right? So curve is equals to convex, okay, and direction is equals to decreasing. It's not increasing, right? If you're using the convex concave now, you have to give the direction as increasing, right? So we have to give the direction as decreasing, DCREA, decreasing, right? So let's just run this. And now just simply run this k1, not kl, not k1. You have to write this kl dot and just simply call this elbow attribute. This is the attribute, and this will give you the value as 3. And here you can just simply check okay. Without using this technique, which is called the elbow method, you can use this for like knee locator, and it will try to just use this WCSS and the value of k, and then it will give you the final value of k, right? Okay, now just evaluate this model, right? If you want to evaluate this model, we have different scores now. If you want to evaluate the unsupervised machine learning model, so you have this model that is called Silhouette score, right? So you can just go to this. Let me just check this spelling, SLH. Yeah, Silhouette score, right? You can call this Silhouette score and just copy this one, silhouette score, and how to call this from sklearn, dot matrices, go to this matrices, you can call this silhouette score. See, this is the validation part, right? You can give your data set or like the errors that you have, and it will try to calculate the score for the each and every model, right? So you have imported this. Now, if you want to calculate the silhouette score for each and everything, so you can just check, right? You can plot the graphs as well, okay? So let's just do it fast. So silhouette score is like the score or like the, it's like calculating the accuracy of the model that we have just created, right? So you can just write it as silhouette score is equals to, or like score is equals to, let's just create this variable and write the value of k for k in range of 1 to 15 we are using now. And let's just call the model again. Model is equals to k-means. Give the value of any cluster as k. Give the initialization as K-means. K-means is like it try to understand one thing. It will like randomly initialize the centroid, but the distance of each and individual centroid must be huge so that it cannot coincide one, or like it must not overlap one to other, right? So K means plus plus, you can use this for initialization, right? Now just call this model and call this fit, and you can call this extrain or like extrain part of the scale part that we are using. Okay, now you want to calculate the scores now. So let's just calculate the, okay, do one thing, instead of calling this score now, it's like the all score. And here you can create the individual methods for like the for the score. Just go to this silhouette score. You can call this silhouette score, and inside you have to give the overall values that we have. So what you can do, you can just simply go to your features, whatever the feature that you have. It's like the X, you have to give the labels, right? So let's just simply give the X train scale, and inside the X train scale, just call this K-means model. Okay, this is the model. Just call this K-means model, and inside this K-means model, you will get this method that is called the labels, right? Why I'm not getting it, right? Just wait. Okay, let's just use this. We have used this as a model now. So model, we will get the value as labels, right? Yes, this one. Okay. So it will give you the score, right? Now, what you can do, you can just simply call this all score and just simply append your all like individual score to this all score. Okay. In this way, candidate, you can get the score by your model at each value of k, right? The number of labels is one, valid values are two to sample one. Okay. So what you can do, you can just simply, instead of starting it from one, now you can just write it for the two. Okay. Now we are getting the score value for each and individual one. If you want to make it like 100% kind of, so just simply multiply this one, and then you will get the value of score at different values of k. Okay. Now just check, it's like the 66, 51, 42, 45, and some sort of like this. Okay. And if you want to plot this one, you can, you know that you have the Matplotlib, you can plot this one, right? So this is your task to plot this graph, so that you can visualize this, what is the value of my, like the accuracy of my model at different values of k. At the value of k, you are getting the score of like 66%, 66%, and 51%, 42%, and followed by the rest one, right? In this way, you can calculate the score, candidate, right? So these are the things that you have to perform when you have the data set like this, the like the clustered kind of data. Then you have to perform the K-means clustering or any sort of unsupervised machine learning, right? So instead of this one, you can use the other models as well. And you know that you have the DB scan model as well, and you can use the like which one? You can use the hierarchical clustering, and then followed by the agglomerative or like the divisive approach. Okay, so let's just simply call this model, or let's just call one data set and do it very fast to just implement the agglomerative approach and the divisive approach for the like this data set, or we can use another data set as well, right? Okay, so let's just start with the hierarchical clustering, right? So the part two is like second model is like hierarchical clustering. So I'll try to keep this fast. The hierarchical clustering. Okay, just go to this. You can call this one hierarchical clustering. Now let's just call this like everything as the we have the data set now. We have already converted the data set, right? What you can just do, you can simply call your model, right? We have that model and we can create, we have the like inside the hierarchical clustering, we can use the agglomerative and the divisive approach now. So let's just call the dendrogram as well and the model as well, right? So how to call the model? So you have to create the hierarchical clustering, right? So let's just go to this sklearn, sklearn import hierarchical clustering, right? You will get this clustering algorithm, and inside the clustering, you can call this one, right? From sklearn.clustering and just call this hierarchical clustering, right? This is important. If you have a like non-linear kind of data set, you can call this one, right? So just go to this from sklearn.cluster import. You have K-means, like uh, okay, let me just check here. This one, agglomerative clustering and the divisive clustering, right? You have to decide which one you can use. You can use the agglomerative as well and the divisive as well, right? So let's just use both one, agglomerative and the divisive one, right? You can use the DB scan. We'll do this in the next part, right? So agglomerative and okay, let's just use this agglomerative and how to call the like the model. Just go to this model, pass this or like initialize this value, and you know that the by default cluster that we are getting is like the 3 value. Okay, so you can just give the n underscore cluster value 3, and you can just you have to calculate the like distance, you know that na, the dendrogram is something based on the kind of the distance between the each individual points, right? Yeah, this one is the Euclidean distance na. So where to pass this one na? We have that like argument, that argument is the affinity. Inside the affinity na, you have to give this one, okay? Affinity, AFFI NITY. Affinity is equals to, why we are not getting the hint of affinity? It's like the metric is equals to Euclidean. Yes. Okay, let's just call this as affinity propagation. See, this is something else, right? So let's just write this as matrix. Matrix is equals to, let's just go to this documentation. Okay, and we have this agglomerative na, and inside this agglomerative, let's just check this one. Yeah, we have this affinity argument, right? We can use this pre-computed and as well as the Euclidean, right? So let's just copy this and go to this affinity is equals to Euclidean. Okay, and you want to like use the linkage between the overall data set, right? Whatever the features that you have, so you have to, this one is the by default argument, that is called the linkage, right? So let's just check this one. Yeah, linkage is equals to WARD. This is the by default parameter that you have to give candidate, right? So you can call this model. Okay, so we have already created the like a variable name with the model now. So let's just write this as a model name as hierarchical clustering. It's like HC. HC is like the hierarchical clustering. Okay, let's just rename this. And you know that how to fit the model, you have to give the extrain part. Okay, extrain scale part, right? Extrain scale. Let's just simply give the extrain scale. Okay, and got unexpected keyword arguments. See affinity, we are getting the unexpected keyword argument now. Let's just change this to matrices. Matrices, right? Matrices is equals to Euclidean matrices, not this one, the metric one, right? Yes, now it's working. See, there might be changes in the argument, right? In the previous day, like we were using this affinity, right? You can just check, affinity is like the kind of distance that it will try to use for the dendrogram creation, right? So we are using this for the metric right now, okay? So you have created this model. Model SC is like the agglomerative or like the hierarchical clustering. Now you want to predict the values or like the labels. Labels is like the classes that the model has the classes or like the cluster that the model has predicted. So just call to this model SC and just simply call the labels, right? So you can call this labels one and you will get the three different labels 0, 1, and 2. Now what you can do, you can just simply go to this visualization part and we have this visualization. Okay, let's just call this one. And instead of this model, we will use the like this one. Okay, the model dot fit in some sort of like this. Simply copy this one, go to this y predicted, click on this plt dot scatter, and instead of this one class, what you can do, you can just simply you can give the title of value of the title as like this one. Okay, and let me just instead of this one just do one thing. You can just call this C as like the C pred, and let me just call the predicted part as well. The predicted part is like model SC. I hope everyone is getting my point, candidate, right? Let's just predict this one. See, labels is the predicting part, right? We are getting the predicted partner. So let's just directly call this. Okay, these are the predicted part itself, right? So instead of we have this instead of predicted method, we have this labels method. It will give the method. It will give the predicted class, right? So let's just store this inside the ypred, and you can give the ypred here, right? Ypred. Okay, and just run this one. And the value of just stop this first. We have created this model. You have to stop this one, right? Okay, the ypred we have already calculated this with the help of this one. What if we have a value of k we are getting the value as 3, and plt dot scatter some sort of like this, plt dot show, and let's just stop this. It's not required, right? C argument has 116 elements, which is inconsistent with the x and y with the size of 400. Right, so right, let's just check what is the value of ypred that we are getting. Let's just check the shape of ypred, right? Ypred dot shape. It's like 1600. Yes, we have the 1600 elements in the C, right? And what about the X test and Y? See, agglomerative inside the agglomerative clustering, we are using the X train, right? Okay. See, okay. What you can do now, because you want to predict it with the Y partner, and we are using this for the X train partner. So let's just give the X test part here. You will again get the value of 400, then you will run this, then you will get the three different labels for the each class. It's like the cluster 1, cluster 2, and the cluster 3. Okay, can it? So in this way, you can use this for the hierarchical clustering. Now, if you want to create the dendrogram, so what you can do, you can just simply go to this module. We have this module that is called the SciPy module, right? Let me just check pip install SciPy. You can import this, pip install SciPy, and once you run this, inside this SciPy, you will get a method that is called cluster. So import SciPy. Inside this SciPy, you have this cluster, and you can call the hierarchy, right? And you can call the hierarchy, or instead of calling in this way, you can just call like this one, from SciPy, right? From SciPy dot clusters, right? From SciPy dot clusters, import the hierarchy, right? Let me just write this. Okay, perfect. And you can just give it as the aliasing. It's like the kind of any hierarchy that you can give. We are using the agglomerative now, so it's like the dendrogram. So just do one thing. You can just simply say this as a anglo cluster. Okay, let's just write this as an anglo cluster. And what you can do, you can just simply call this anglo cluster. Inside this anglo cluster, you have this method that is called the dendrogram. And what you can do, you can just simply call your all the data set, right? Whatever the data set that you have. So for that, you have to go to the linkage part. So we have this linkage part inside this anglo cluster, right? Linkage is like we want to link our odd data. It's like we want to create the dendrogram, so we have to create link our all the data. So inside this anglo cluster, we have this linkage method, right? And inside this linkage method, what you can do, you can just simply give your any data set that you want to show the dendrogram for the same, right? And you know that the method is by default word method, right? So you can just simply give the word method here and it should show the graph. Let me just run this plt.show. It will take some time, candidate, right? See, we are getting some sort of dendrogram right now, but the problem is the problem with the like the figure size. So what you can do, you can just simply go to this plt.figure, and plt.figure. Inside the figure you can call the fixed size, and the fixed size is like, let's just increase the fixed size as 25 and the value as 5. And this is the dendrogram that you can create, and you can give the plt.title as well, dendrogram for hierarchical clustering, right? SC. Let me just run this, right? So this is the final dendrogram, and you know that inside this dendrogram, you have to find the longest vertical line, and this is not the longest vertical line. See, if you just pick this longest vertical line, it will try to cut this with this one horizontal line, right? So this dendrogram helps us to easily identify the value of clusters K also, right? But inside this, see, this SciPy only helps you to create this dendrogram, right? If you want to calculate the value of K now, so you can just use the like agglomerative clustering as well, or you can use the like the knee locator, or you can use the K-means as well, right? For the different set of data set, right? Now I'll give you some sort of example or like homework for all of you guys. What you have to do, you can just try to just identify the score for this agglomerative clustering as well, right? And the homework is you have to just again repeat the same step for the DB scan model, okay? Just do the same for the DB scan model, and we'll just simply understand the use of DB scan in the next class. It is also helpful for the non-linearity kind of data. Let me just show the example like this. Okay, if you have the non-linearity kind of data like this one, so we can use this the DB scan for the same, right? So we'll try to understand the DB scan or like the practical implementation in the next part, and then we'll probably start our project with the help of like supervised learning for the supervised learning and for the unsupervised learning as well, right? Okay, candidate. So this is for the today. Just let me know, Taruna, or like the rest candidate. Is there any doubt? See, the main purpose of this unsupervised machine learning is to create some clusters. The clusters should be, it's like the matchable features or like the same features should fall inside the same cluster. That is the main purpose of this kind of algorithm, right? Whatever we are creating or like we are using the model and just for the sake to create this kind of clusters, we have to reiterate the process with the different values of K. And you can use the dendrogram technique as well. You can use the knee locator as well to identify the best value of K. Since we know that with the help of ELVO method, we got to know the value of K is 3. So that is the reason we are again creating the model with the value of 3. And if you are using the 3, because the data set that up to is the value of 3. If you just go to this data set, like this one, okay, if you change the value of 3 to 4 here now, then you will have to create the model, or because we have already created the model, so you will get the 4 cluster instead of 3 1, right? Let's just run this. You'll get everything as the 4, right? You can just simply go and try and check, right? We are getting the 4 different clusters, right? Now the model will try to understand the different set of features, and then it will give you the 4 different clusters. Okay, so you have to like take a reference of this data set and then try with the another like the different centroid features that you want to get, right? Okay, so guys, this is for the today. Just let me know any doubts or any question, candidates. Class, is it fine? Okay, so let's just connect tomorrow for the DB scan and for the final project part as well, right? You can just have a look of the, like, you can take a reference for this video for the final understanding, and let's just connect tomorrow, right?